A warm welcome and applause to Zdravko Dimitrov from Homeport. Zdravko, the stage is yours.
Hello, everyone. I'm going to talk about Homeport and in general about the decentralization of space infrastructures and data. A bit about what we do. I'm essentially one of the co-founders of a Bulgarian non-governmental organization called the Sat1 Initiative, which was established 2 years ago with the purpose of promoting space technology development in Bulgaria. Until now we have 14 members with quite diverse experience from some of the largest institutions and companies in the space sector in the world. And the Homeport is essentially an idea which was, it appeared there. And we subsequently set up a small team to work on it separately. But before we get to the actual space technology sector and in general about what we do, I'd like to give you a bit of a backstory about what the whole thing is. The space industry, space science, in general how things are organized, because a lot of people generally, when they hear space, they imagine Elon Musk, we're going to go to Mars, lunar exploration, things like that. But there's a lot of dynamic, there's a lot of processes and things going on behind all of this that for many people remain unnoticed. And we essentially, the way we're positioned is going to be explained by how the entire sector has evolved. We can start by the fact that space technology in general began as something that was highly secretive, highly centralized and under military control, because we still go to space by rockets. Rockets were in their pioneering years in the late 40s, early 50s. They were basically completely controlled by military programs until the late 1950s when so-called intercontinental ballistic missile, which is essentially the first space launch vehicle, was created and then used to subsequently launch satellites, which marked the beginning of the space race. The culmination of this old era, when we had the space race and during the Cold War, was the so-called moon race, when the two major space powers, the United States and the Soviet Union, competed to send a man on the moon, which is the so-called moonshot. Which is an interesting illustration of how things stood back then, and that is that in essence, centralization in those years was actually beneficial. It was quite beneficial because if you look at the United States, which had tremendous industrial, scientific, technological capacity, they had massive amounts of human capital, a massive amount of companies and actors going for the Apollo program, and all of these were managed and essentially overseen by NASA, which coordinated this entire effort as a central singular institution with a lot of political will behind it. Whereas if we look at the then Soviet Union, which also attempted a moonshot, they also had enormous industrial and technological capability, but a lot of these institutions actually competed with each other. They didn't really synchronize their activity. At some point there were about 30 different moon rocket projects. And from the beginning there wasn't much political will as to whether they should go to the moon or not. And the end result was that the centralized approach of the United States resulted in them having 12 people walking on the moon, whereas the Soviets didn't have any. And since then, of course, things have changed quite a bit. Essentially for several reasons, and that is that we no longer have these large companies. We still have them, but the tendency is that they no longer tend to manufacture everything in-house. They would rather prefer to use their decades of experience to integrate and assemble things that were essentially manufactured by others, subcontractors, smaller companies, and so forth. The other thing that we have nowadays as a major difference is that we have a huge demand for space data. which if we look at these numbers, this is just a fraction of why it is so. 90% of all trade we have, that is oil, that is commodities, that is pretty much everything that you use and that you need, is delivered from one point to another by ships. All of these ships are tracked by satellites. You can find the position of a ship by satellite. You can use the satellite to estimate whether that ship is going to be delayed, what's going to happen to essentially the goods you're delivering, and so forth. We have an ever-increasing amount of damage caused by calamities because of climate change. And much of the damage assessment that is done is being also done by satellite imagery, because a satellite can oversee a vast area quickly, and you can use different types of data to essentially establish the needs. And last but not least, from this example, is that 2.5 billion people in the next 30 years are going to become urban dwellers. And what we have now is instruments of basically defining where these people live, and what we do is inefficient instruments such as census, statistical information that is collected in very antiquated means. Whereas if you have satellite observations of heat signatures, supply routes, and so on, which is already used, you can actually have a much more meaningful overview of what is going on and what is changing. And essentially, satellite imagery, which is the main type of space data, is driven by a number of factors. As already mentioned, urban development is one of them, but there is also agriculture, which is becoming increasingly efficient through the use of satellite monitoring of crops, border security, domestic security, and intelligence are also deploy satellite data, disaster management as well. And this is a sector which is projected to increase massively in just the next few years. And why is that? Because for now, we also have just 50% of the global population having access to the internet. But when we have internet constellations, that is constellations of satellites delivering internet to the rest of the population, that's 3 billion people, we're going to have also those 3 billion people making use and having access to satellite data, including Africa, which is a mostly agricultural, where the economies are mostly agricultural. And as a result, there's going to be a massive increase in usage of that. And finally, we have decentralized storage, and especially machine learning and AI, which space is huge. The amounts of data that are processed and delivered every day are just colossal. And the best way to essentially utilize this data, all of this information, all of this huge set of numbers, the most efficient way to crunch them will be through machine learning and analyzing, especially in imagery, through AI. So what this means is that we're having an ever-increasing amount of people on the chain using all kinds of data, all kinds of equipment, something that cannot be any more controlled by centralized assets, so we need different tools for that. So Homeport is essentially something that works on a very key segment of the satellite data sector, and that is because every satellite that's in orbit, it needs a ground station. That is a receiver, which basically receives the signal from the satellite, so that the data can then be delivered to the appropriate user. We have many of those receivers across the globe in different frequencies, different locales. But the thing is that there is not always, the operator of a satellite not always has good access to that. This is why I have growth in something called ground stations as a service. Therefore, we have some of these receivers being contracted. But what Homeport does is it allows all of these receivers to be connected into a network. So if you have satellites, you can easily access the network and request specific receivers to obtain the data from the satellites that you operate, which is pretty much the basic premise of what we do. And through using a smart contract, we can allow a very direct, very flexible interaction between the company that operates a satellite and the institution that operates a receiver. As already mentioned, the smart contract is the principal tool of enabling this marketplace for data and for ground station capacity. Basically, the network of receivers is decentralized. It has no cap. It has nobody controls it. Each receiver basically defines the price at which it sells its receiving capacity, thus forming a global decentralized marketplace with a very diverse set of conditions. I'm going to have a small prototype. It's not completely, it's not the complete thing. Just to basically showcase how things go. So for the client side, there is a very simple interface with a dashboard. It's over there, the dashboard. So if you operate a satellite, essentially what you're going to be seeing is an overview of essentially all the stations available across the globe. You can see essentially the rates that they want, so that you pay them to get your data. Yeah. Yeah. There's no connection? And essentially, what this application, it's pretty simple, solves is the access. Because if you have a satellite, you normally need a ground station. Ground stations are pretty expensive, so you can scale up satellites. You can make many of them. Nowadays, they're pretty cheap. But what doesn't become cheaper is the ground station, because you need people operating it. You have maintenance expenses such as power. You need licenses for that. And in order to cut down on these expenses, the easiest thing that can be done is to contract existing stations and use their idle capacity. So basically, this is the very basic idea of how things work. Yep. What's the password?
No, it doesn't work. So, but the time is up, so
Okay.
thank you very much.
Yeah. So that's it very much. Thank you.